Topic would be on truss blocks, truss bearings, and its function.
Truss bearing, location and function. Let us assume this to be the aft portion of the ship. We have the propeller here, marked propeller, and the propeller shaft or the tail shaft comes inside the ship through the stern tube bearings. Propeller or the tail shaft is marked here, and the blue shaded portion or the stern tube bearings which support the propeller shaft, and here is the connection between the propeller or the tail shaft and intermediate shaft. This is the flange, and the intermediate shaft runs over here, which is supported by the intermediate shaft bearing. This is the intermediate shaft bearing, and this is connected to the flywheel of the main engine. This is the flywheel, and I have marked it as flywheel over here. Let us assume this to be the main engine complete structure. The last portion of the main engine is having the thrust block. It is integral part of the main engine. 20 years before, or maybe 15 years before, you will be finding the thrust block outside the main engine. The thrust block forms a separate unit to absorb the propeller thrust. But currently the recent trend is to make the thrust block an integral part of the main engine at the aftmost unit. And after the thrust blocks comes the main bearing, the crank web and the crank pin, and again a main bearing, and thus the crankshaft continues. All the main bearings and thrust bearings are supported by a bed plate, that is main engine bed plate, which is bolted down to the ship's hull. The intermediate shaft bearing is also bolted down to the ship's hull, and the stern tube bearing forms a part of aft peak bulkhead and tank. As the propeller rotates, it creates a thrust which is called as propeller thrust, which is taken up by the propeller shaft, and this is passed on to the intermediate shaft. This happens because the propeller shaft and the intermediate shaft are connected together, and the thrust is further avoided by the thrust block. The main reason why thrust block is placed at the aftmost part of the engine is the crankshaft should be saved from this propeller thrust. The crankshaft at any cost should never be subjected to the propeller thrust. Thus, the thrust block is placed at the aftmost part of the main engine such that any part of the crankshaft is not subjected to the propeller thrust. And this thrust block has thrust pads. Simply, I can say this is the crankshaft, and here we have thrust pads. Here also we have thrust pads. When the propeller thrust is offered in a head direction, these pads take the propeller thrust, and thus they do not offer any further motion to the crankshaft. When the ship is going in astern direction, these pads take up the propeller thrust. So the thrust pads absorb the propeller thrust, and since the thrust pads are located inside the thrust block, which is bolted to the main engine bed plate through the holding down bolts, the holding down bolts are bolted to the ship's hull, the ship starts to move.
This is the pictorial representation of the entire shafting system of a ship. As I said earlier, here is the propeller connected to the propeller shaft, entering the ship through the stern tube seals, and it is connected to the intermediate shaft. The intermediate shaft is mounted on the intermediate shaft bearing, and through the reduction gear it is connected to the flywheel of the main engine and to the crankshaft. As I said earlier, the thrust block must be located after the crankshaft, but it can be located anywhere along the shafting system. Now let's see what decides where the thrust block must be located, or where exactly the thrust block must be located on the entire shafting system. For that we have to know about nodes and antinodes. So what are nodes? As we all know, node is a point where there is no vibration, or the amplitude of vibration is zero, and antinode is just opposite of it. Antinode is a point where the vibration is maximum on the shafting system. Let's see exaggerated shafting system's vibratory characteristics. Here we have two nodes and one antinode on this vibratory curve. This is the point where it vibrates maximum, and here there is no vibration or minimal vibration. Let's see the next picture. Here again, the node, there is no vibration at all or minimal, and the antinode is the point where there is maximum vibration. So the thrust block must always be placed at the nodes, not at the antinodes. So the thrust block can be placed at any of the nodal points along the shafting system. Thus it's always better to position the thrust block at the nodal points where the vibration is zero or minimum. If you fit the thrust block at an antinode, the vibration is maximum and it will be subjected to huge stresses. So the thrust blocks must be located at nodes. Let's now see where does the chain or gear drive is located. The Sulzer engines have the gear drive and the BMW have the chain drive. Both the drives, chain or gear, should be located at the nodes or the near nodal points, not at the antinodes. If the drive is taken from the nodal point, the turning moment is even. There is no undue stresses on the drive gears. So this is the pictorial representation of the BMW chain system and the Sulzer gear drive system. But you must be wondering where to fit the dampers and detuners. Let's see the shafting diagram once again. As you can see, the vibration curve over here with the red line, the thrust block is located at the node or near node. In the same manner, the vibration curve goes up like this, and the damper is fitted at the antinode or near antinodal point wherever possible. The main reason is that if you fit the detuner or a damper on a node, it will not be effective, or it will not dampen the vibration properly. So the detuners and dampers are fitted at antinodes so that they can dampen the vibrations effectively. Now the question should be why the thrust block is located near the main engine and why not near the stern tube. This is most frequently asked in the oral examinations. Alright, let's observe the picture. If the thrust block is placed near the stern tube, there is very less area for the propeller thrust to act on, and since the area is very small, you require more additional stiffening members to withstand such a huge thrust. And there is also one more reason. The number of nodal points available near stern tube are comparatively very less. Let's see the next picture. When I place the thrust block near the main engine, the cross-sectional area is comparatively larger for the propeller thrust to act on, and it doesn't require any additional stiffening member as the thrust block forms integral part of the bed plate itself. So the thrust force from the propeller when taken up by the thrust block located near the stern tube have lesser area to distribute to the hull, and the number of nodal points are fewer near the stern tube.